share the card. My dear friends, we have started parallelly another topic of engineering, procurement and contracting commissioning of 66 by 11 kV substation, in which we have seen what are the activities to be done that we have seen. But all the time, we also were wishing that we should know something about bus bar arrangement, because no doubt 66 by 11 kV substation will have single bus bar arrangement. But if you go for 132 by 66 kV, then 132 kV may be double bus. So bus bar arrangement we should understand. So I think in video number 1, we have understood single bus bar arrangement, uh, uh, single bus bar arrangement with sectionalizing isolator, and single bus bar arrangement with sectionalizing breaker. Yet two more important arrangements are pending, and that is what we will be learning in this video. Arrangements are only two, but quite complicated. Therefore, this video also may take 1 full hour of time. So you will have to be ready to hear it for 1 full hour. But take it from me that this is nowhere written in the book, right? So this is very important. And in substation, the line staff, the engineering staff does these kind of sequential arrangement while operating the bus bar schemes. Therefore, this is very important. Therefore, please uh, nicely here, if possible, here 2 times so that you can understand it well. So, double bus bar scheme, we are going to start here. There are 2 buses, main 1 and main 2. So, obviously, the cost is going to double. Main bus 1 means there are 3 RYB. Main bus 2 means again 3 RYB. So, and the capacity of bus is usually same. Both are identical. The current capacity will be same. So obviously the scheme is going to be costly. Not only that, because we are going to use 2 buses, the space will also be more. So that will also be costly. Roughly half the power is transferred through main bus 1 and other half through main bus 2. That is the usual understanding. You see, because through one bus, if you transfer full power, then the ampere capacity may be very high and then the cost will be too high. So, you see, one bus can take full power for some time, but not for 24 hours and 365 days. So, what is the arrangement? Arrangement is like this. I1, I3 and I5 I am telling incomer, and I4 and I5 am telling outgoing feeders. But because this is double bus arrangement, You see, single bus arrangement, usually power comes from one side only. On the other side, there is load. But in double bus, you cannot say so. Uh, the generator may be on all the 5 lines. So the direction that I am showing is only for showing. In some other case, I5 may be outgoing also, and I4 or I5 may be incoming. So you cannot say that this is incoming, this is outgoing. But right now, I am telling I1, I3 and I5 incoming. I4 and I5 are outgoing. Now main bus 1 and main bus 2. Try to understand, this is single line diagram. So every single line means 3. I1 and I2, I3, I4, I5, I6, I7, I8, I9, I10. On both the sides of the breaker, the isolators are there. B1, B2, B3, B4, B5 are breakers as usual. One more thing is added. 5 more isolators. 5 means actually 15 because this is single line diagram. BPI1, bypass isolator 1, bypass isolator 2, bypass isolator 3, bypass isolator 4. I'll show you bypass isolator 4, bypass isolator 5. Then there is going to BSI1, bus selection isolator 1, bus selection isolator 2, 3, 4, 5, 6, 7, 8, 9, 10. What are we doing? That the power for number 1 is incomer, whereas bus 2 is going to main bus 2. Line 3 is to bus 1, but line 4 is to bus 2 and line 5 is to bus 1. So that's how I have divided. Roughly half of power is divided. Bus selection isolators. By that we select the buses. Then these two buses are coupled by bus coupler. A breaker. Bus coupler is a breaker. And then on both the sides there are isolators BCI1 and BCI2. This is the whole scheme. This is all written here, right? So this is how the diagram looks like. Now, what is the normal condition? Diagram is repeated and the normal condition is shown. I1 to I10 are on, obviously. All isolators you have to keep on. B1 to B5 on. That obviously you have to keep it on normal condition. Power is flowing under normal condition. BSI1, BSI3 and BSI9 are on. Zara dekh lo. BSI1 because we are taking power to bus 1. BSI3 that is on because that we are BSI1, BSI BSI1, BSI3, that is probably wrong. BSI2, BSI4, BSI2, BSI4 is off. BSI4 cannot be off because if you keep BSI4 off, then power cannot go like this. No, it's okay. BSI1, BSI3, it is on, and BSI9 is also on. So BSI1, 3 and 9 are going to bus 1. But the counterpart BSI2, BSI4 and BSI10 are off. That means the power from these 3 is going to power from 1, this that is breaker number 1, breaker number 4, breaker number 2 and breaker number 3 is going to bus number 1. Then BSI 6 and BSI 10 are on. BSI 6 is on means it is this power incomer 3 is going to bus number 2 and BSI 8, that means BSI 8 is on means this is on means this power is going to bus number 2. BSI 8 is on means BSI 7 must be off. So BSI 7 and BSI 5 are off because BSI 6 is on. Right. BC is on. Bus coupler is always on. So both the bus are live. And BCI1 and BCI2 obviously both the isolators are also on. BPI1 to BPI5 are off. Now we are not bypassing. We are passing the current through breaker. So bypass isolators are off. So this is how we are looking at. Now the next thing. Next thing. What is the next thing? Yes, sorry. Next thing is this is because isolator. Now what we are doing? You are seeing the fault on bus 1. If there is a fault on bus 1, now when there is a fault on bus 1, you see bus 1 and bus 2 are also connected because bus coupler is on. So once all breakers B1 to B5 will be tripping, therefore the complete power on this substation will go, consumer will not get power, and power system will not feed power to this. Therefore there are quite possibilities that, and this double bus scheme is big substation, maybe 500 MVA substation. So there are every chances that the power system may become unstable. So power system stability is not granted. Power system stability is not granted. But if power system does not become unstable, then you need not wait till you repair fault on bus 1. What all you have to do? Make BSI2 on. You see, that is very important. Make BSI2 on. Where is it written? Yes, it is written here. Make BSI2, BSI4 and BSI10 on. See, BSI1 was on. So BSI2 make it on. BSI1 को आप नहीं touch कर सकते. When you make BSI2 on, this is also on, this is also on. So power will flow through both the isolators. So you are making BSI2 on with power on load. And you have been taught that isolators cannot be operated on load. That is wrong. Isolators can be operated on load if either the power is not flowing, current is zero. That is, it is unloaded operation. Then you can operate. And second condition, if both these points, that means the points at which isolators are there, are at same voltage, then even if the current is passing, you can operate. Because same voltage means there is not going to be any arc, right? And this voltage and this voltage is the same. Why? Because this voltage is this voltage. And this voltage is this voltage because BS7 is on. This is going to this through bus coupler and this and we are coming to here. So this and this voltage are same. So you are making BSI2 on. You see, this is a sequence. You cannot make BSI1 off first. BSI2 on. BSI4 on. And BSI10 on. Then make BSI1, BSI3 and BSI9 off. Because at that time also when you are doing, it is on load, current was passing, but the voltage difference was zero. Therefore, you could do this operation. After completing this, make BC off because bus coupler can be made off on load because it is arc quenching facility, right? So make bus coupler off. Once you make bus coupler off, make BCI1 and BCI2 off. You see, when you do this much, when you do this much, your this bus is empty because BSI2 is off. You have made it off. BSI4 was already off in the earlier operation, right? Uh, BSI4, BSI3 you have made off. BSI 9 also you have made, sorry, BSI 9 you made on. What you have made of BSI 1 and BSI 2 of BSI 1 and BSI, BSI 1 and BSI 2 you have made of. BSI 5 was already off because it was on another bus, right? So all other isolators BSI and BSI 6 also was off, and BSI 10 you have BSI 9 you have made off. So now your bus number 1 is empty. It is not, it is evacuated. There is no power. So you clear the fault. If it is sustained fault, you take 2 hours, 3 hours, no problem. Then the power, complete power will be on main bus 2. It is quite possible that main bus 2 may not be able to take that large current. So little load shedding you may have to do. That is quite possible. That is quite possible. But complete power will not go. Full flexibility is there in double bus scheme. So all schemes 132 kV and above are using double bus scheme. If I go further, uh, breaker 1 is to be maintained. Before that, fault on bus 1. Fault on bus 1. Before that, yes, it's okay. I'm not talking about the breaker maintenance, but breaker maintenance also can be done like that. If you want to maintain breaker 1, then there is no problem. You do the same sequence as you do for fault. Main bus 1 is empty. Uh, Maintain that bus and then uh, make everything regular as it is. If you want to maintain bus 2, evacuate bus 2, and then once the maintenance is over, make everything as normal, right? But when fault occurs on bus 1, what happens? When fault occurs, all the 5 breakers will trip. That is one thing. But once all 5 breakers will trip, then what you have to do? You make BSI 2 on. See, same sequence which we are doing in uh, uh, maintenance, or rather when we are doing on uh, 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 maintenance of bus. Or so same thing, BSI 2 on, BSI 4, BSI 10 on, other things off, BC off, make BCI 1 and BCI 2 off, and now make B1 to B5 on, because on fault that become off automatically by bus protection scheme. Make it on, but bus 1 is evacuated. Uh, Clear the fault, repair the bus 1, and then make the thing normal. You see, that is possible. So in case of bus fault also, all the consumers are being fed with the power, right? Some consumers may not be fed, some load shedding may be done, but minor load shedding. Otherwise, all the people are fed load. That is the advantage. That is the very important advantage. Now, another important thing, you want to maintain breaker 1. You want to maintain breaker 1. Now, when you want to maintain breaker 1, you will have to disconnect I1. But you see here, because there is BPI1, you will not have to disconnect I1. Means you will yet receive power or feed power, no problem. But sequence. What is the sequence? First, you will have to make BS this bus, I mean bus 2, you will have to make it clear. Bus 2 clear के लिए क्या करना का, make BSI 2 on, BSI 2 on, and BSI 1 off. So you're now this incomer is coming to bus 2. Then make BSI 5 on. BSI 5 को आपने ऑफ किया था, उसको ऑन करना पड़ेगा. BSI 5 on and BSI 6 off, right? BSI 7 on and BSI 8 off. वो बंद करना, मतलब कि ये बस पर ही लेना पड़ेगा उसको, राइट? BSI, सॉरी, BSI 8 off means ये बस पर नहीं, ऊपर वाले बस पर ही लेना पड़ेगा. Make BSI 5 on BSI 5 on means you are taking the power on upper bus. BSI 7 on means you are taking on upper bus. BSI 9 is already on, so no problem. Everything has happened. Now what you do? Make BPI1 on, this bypass isolator. First you have to make this on. This is on-load operation, you see, because current is passing like this also, and parallel half the current will pass like this. On-load operation. But because these 2 points are on the same potential, you will be able to do that. No arc will occur. Then once you do that, then make breaker 1 off. Make breaker 1, you have to make breaker 1 off. And then make I1 and I2 off. So now you easily maintain breaker 1. You are not losing power from I1. That means incomer. But now the problem is, if there is a fault on that incomer, who will operate? Otherwise B1 was operating. But now B1 is under maintenance. B1 is already off. Then who will trip when fault occurs? Because relay cannot trip. Relay cannot take tripping current. Breaker only has to trip. So now you see what is the sequence. What is the sequence? How the current is passing. Say there is a fault in this. There is a fault in I1, right? So if there is a fault in I1, I start from here. 4 में से मैं देखता हूँ. 4 में से कैसे करंट गया? Before is on. Hey. Before is on. Before is on. Before is on. And then BSI 4 is off. Sorry, BSI 4 is BSI 4 was already off on. So power will go to BSI 4. Power will go to BSI 4. Power cannot go to BSI 2 because BSI 2 is sorry, BSI power. No, BSI 4 is off. BSI 3 you have made on. BSI 3 was already on. So you see, power from this will go to BSI 3. Then it will go like this. Right? It will go like this. Then it will go to bus coupler. And from bus coupler, because you have made BSI 2 on, it will go to line 1. So whatever the fault that has occurred, relay sense the fault and relay will trip bus coupler. So bus coupler will rather trip, and bus coupler will take the tripping power. Bus coupler will take the tripping power. Bus coupler will isolate the faulty circuit. That is, the work of B1 will be done by bus coupler. So power to I1 will yet be fed or yet be received, whatever. There is no problem if you are maintaining the bus. That is the work done by BPI1. So that is the advantage of bus coupler. You are not tripping any power. That is the added advantage of this bypass isolator. But one more thing you will have to do. You see, relay was tripping 52 BC1. 52 BC1. 52 BC1 means B1 trip coil was tripped by relay. But now B1 is under maintenance. So what you will do? Instead of B1, you will trip the trip coil of bus coupler. And for doing that, you will have to change the control switch from A to B. This control switch is in control room. All other things which I showed to you are outdoor, but this control switch is in control room on every panel. So this you are changing from A to B. You have to do that. That operation you have to do. So when you do that operation, when relay operates, it energizes 86. Energization of 86 will then trip bus coupler. So bus coupler will give the tripping signal. Bus coupler will act in place of B1. Bus coupler will isolate the uh, faulty section. What is the meaning of all these things is written here on left hand side. You can read through. So this is the double bus scheme. So we have seen everything, however, we just see through the features of double bus bar scheme. If you see the double bus bar scheme, you will find that there are many disadvantages, but it is not so. The main big advantage is it is highly flexible. You are feeding power to the bus. Even if there is a bus fault, even if you are maintaining the bus, you are not losing power. So the electricity board is losing, is not losing revenue also, and the big industries are not losing production also, and the uh, the uh, people are not feeling discomfort also. But if you read, you will feel that there are more disadvantages, because when this system of bypass isolator was used, bypass isolator, now few people have disconnect, are not using bypass isolator. So that advantage of maintaining the breaker, even if uh, feeding the power to the line, is not available if you do not use bypass power, because certain failures were uh, seen by people. Power flow and reading the schematic is left to the reader, which I did read. I did complete the scheme. So what are the features of the double bus scheme? Cost of one more set of bus is added. Cost of bypass isolators is added, because we are using bypass isolators. And one means not one, because it's single line diagram. Cost of one bus coupler and associated isolators is added. So very costly scheme. And not only cost, because of that the space requirement is also more. So land is also costly. So very costly scheme, but very flexible. The scheme occupies large space. Therefore, large land area required. Thus, once again, costly. The arrangement and sequence of operation is quite complex. You see, you have seen this, no? It is so complex that skilled persons are required. Highly flexible scheme, that is very good advantage. No discontinuity of power for bus or breaker maintenance. And there is a little while discontinuity of power when there is bus fault, 3 or 4 minutes. Within 3 or 4 minutes, power system instability can occur. So that disadvantage is there. But if it does not occur, then you have to just by some changes, you can take the power to only single bus. Power system stability is not guaranteed. That is certainly there. Complete dark out in case of bus fault for few minutes, because you see all the breakers will sleep. So till you make the switching for 3, 4, 5 minutes, complete dark out will be there. But very short downtime in case of bus fault, because while you are doing bus fault rectification, bus 1 fault rectification, power is passing through bus 2. So there is no question of downtime. Even if fault occurs, then also there is very small downtime. And when you are maintaining the breaker, you are not interrupting power from that line. So there is also no interruption of power in case of bus maintenance. So these are all the features of double bus arrangement, right? Then the last scheme is 1.5 bus scheme. Very costly, very complex, but very good scheme. Very good means the disadvantage of power system instability is also not there in this scheme. So that I will show to you in the figure, right? I'll show you. This is the 1.5 breaker scheme. So actually, as I told to you, half breaker means you cannot cut breaker in two parts. What is the meaning of half breaker? Between line 1 and line 2, there are three breakers you can see. So for two lines, three breaker means for one line, 1.5 breaker. So that is why the name 1.5 breaker. Diagram you are seeing, there are two buses as in double bus scheme. But there are three breakers and therefore six isolators. And six isolators means 18 isolators because this is a single line diagram. So there are 18 isolators total. So there are 36 isolators. One thing. Such a scheme is used for 400 kV and 765 kV. 132 and 220 double bus. I once again tell 6.6 kV, 11 kV, 66 kV single bus, 132 kV and 220 kV double bus, and 400 kV, 765 kV, 1200 kV 1.5 bus, because they are taking very large power, and power system instability you cannot, you cannot allow power system instability. Therefore, however it is very complex and very costly, you have to use 1.5 breaker scheme. You can see cost because you see many isolators are there. And now you think I am using for 400 kV. So isolating distance when isolator is open is large. Isolating distance is large. So for 18 isolators, it is so large a distance that you will need a very big land, and therefore you will have to pay. Electricity board also will have to pay to the person from whom they rather uh, uh, purchase land. So what do they do? What they actually do? That the isolators are not horizontal, isolators are becoming on and off vertical. As you have seen, isolator on the traction engine, electric traction engine. That is, when isolator is on, it is shown, and when isolator is off, it is shown. Right. So vertically you are keeping, and vertically there is no problem. Vertically you do not need. You are not to pay vertical distance. आपको you are not to pay. So isolators I1 to I18 are vertical isolators. And you can see there are multiple paths of feeding power. Say for example, line 1 to line 2. How can I feed power? Line 1, I3, B2. I'll show. See, I'll show so that you can. And I'm showing line 1, I3, B2, I4, and line 2. This is one possibility. Another possibility is line 1, I2, B1, I1, then this I7, B4, I8, right? Then I9, B5, I10, I11, I10, right? I10, I11, I10, you're going up to I10, and then you feed power from I10. How do you feed? You are feeding power like this, right? So you can feed power through another line in another way also. From I1 to I2 also you can feed power. That is also possible. If this is off, then also this is possible. Line 1, then this I2, B1, I1, and you are coming to this bus. When you come to this bus, you have to go to second bus, right? You have to go to second bus. Have you go to second bus? You go to second bus like this. You go like this. I7, B4, I8, I9, B5, I10, I11, B6, I12. This. You're in this bus. Then you go like this. Then I6, B3, this isolator, and this So you see, another way of feeding power from line 1 to line 2. There are multiple ways, and therefore you can uh, maintain multiple breakers. In case of one double bus scheme, you can maintain only one bus at a time, because bus coupler can do function of one bus. Here you can feed two or three breakers also at a time. So, and power is available to the consumers. Power is fed by the electricity company. So electricity company is not at loss. The consumers are also not at loss. But, and say, if there is a if you want to maintain bus 1, simply make B1, B4 and B7 off, and make these isolators off. Then power is on another bus. So bus 1 you can easily maintain. If there is a fault on bus 1, B1, B4 and B7 by bus protection system, which I have not shown here, because we are not talking of protection. B1, B4 and B7 will trip. They will trip means bus 1 faulty part is disconnected. Power is now on bus 2. So no, so to say, instability of power system. So this is the best system. No disadvantage, all advantages, all features are advantageous. Bus fault, bus maintenance, breaker maintenance, whatever you tell, you can do. This is the best scheme, but very costly scheme. Very costly scheme. That is the disadvantage of this. As I told to you, the vertical isolators are used that we have talked about. Features of 1.5 arrangement is very complex. You need a skilled staff. The arrangement is very costly also, but highly flexible. Very flexible for bus fault, for breaker maintenance of line breaker, or for bus maintenance. It is very flexible. No power system instability. No power system instability. No discontinuity of power flow to consumers. Power system stability is fully guaranteed. These are the advantages. These are the there is no problem of dark out. Dark out hoga hi nahi. People will not know that there was a fault on bus. People will still get power, and electricity board will get revenue. There is no problem of downtime, because when one bus is being maintained, another bus is working. No downtime, no interruption time. Breaker can be maintained without interrupting power, and you can maintain more than one breaker. Bus bar maintenance also can be carried out. You have to make some schedule, but according to schedule, you can do bus bar maintenance also. Very good scheme, but very costly, right? After talking so much, I am completing this. You see, this engineering, nobody knows. Only those who are working in the industry know. They know because they learn from their bosses. It is not written in any book. Now this I am teaching you. You can do it without asking anybody. This is I have talked only about bus arrangement. We are yet going to talk about how much land is required for 66 by 11 kV substation. And we will make the specification of all items of the uh, power, I mean 66 by 11 kV substation. Not only that, but we will learn a little, because you see, you should know what is the function of breaker, what is the function of isolator. So that also we will learn. So we will learn a lot, not written in any book in the world. You see, it is not available anywhere. So this is very, very useful. So please go through this, right? But for that you will have to stay tuned with Head-Up-Me. You cannot forget Head-Up-Me. Not only that, you share to as many friends as possible, so that Head-Up-Me is known all throughout world. Till then, my friends, I thank you very much for hearing me patiently for a little more time, and good day to you. Thank you very much once again.